is L1 or L2, guys? L1 is for lasso, L2 for ridge. So which one reduce the coefficient to 0? L1 or L2? Lasso, L1, right? So when the coefficients are reduced to 0, so lasso regressions also called as feature elimination technique, isn't it? Feature elimination techniques, guys, right? And so I hope we clear what is lasso, what is ridge, we completed. Now elastic net. What is elastic net? It is a combination of L1 plus L2. It is combination of L1 plus L2. Are we clear or not? So it is lasso regression, also called as feature elimination technique. And this is elastic net, we called L1 plus L2. So what is L1? Lasso regressions inherit the properties of feature eliminations, and L2 inherit the property of multi-collinearity. Okay, then when we combine both multi-collinearity, when we combine both, then this is called regularizations. Now, my questions in interview, if someone asks you, what is the overfitting reducing technique? The first one is regularizations. Now, will you explain how regularization reduce the feature? How, guys? Anyone? It scaled down the feature to 0. When it's scaled down, the features are eliminated or not? So rather than I trained with 4 attributes, I trained with how many attributes, guys? Just 2 attributes. So we reduce the overfitting and we get a best accuracy. We reduce the overfitting and we get a best accuracy. Are we understand or not, guys, till that part? Now I'll give you one practical, then I'm heading toward classifications practice, guys. Then I'll heading toward classifications. Just go ahead and, okay. Okay, I have one data set, okay? And everything, no, look at the Seaborn, Matplotlib, pre-processing. Are we done SVR algorithms or not? In SVR, can you open, you can find a regularizations technique, L1 or L2. By default, which one we implement? Please check and update me. Guys, are you understand? And today, I plan in, when you speak the student story, you got to understand? Somewhere are you connect or not? This is what happened. Where you don't know the concepts doesn't mean that you never learned. That means we need to do hard work. Very simple. That's what she said. And that's what I keep on saying. Yes, yeah, I know you're doing, because so that's the difference. Working professionals can understand what exactly programs is all about. Freshers, they don't understand. Anyway, I'll go ahead and we can continue this one. Very good. So, pre-processing polynomial train test split linear ridge lasso. From sklearn.linear model, import linear regressions and lasso regressions and ridge regressions. Did you see? From sklearn, which model? Linear model or not? Linear regressions, lasso regressions, and ridge regressions. I call the 3 package. When I called sklearn.ridge, in backend, the ridge formula alpha plus penalty has called up, guys. Understand? And when we call lasso, we don't have square, isn't it? But in ridge, we have square. Remember this too, penalty. When I explain, just go down, assume I have some of the car data set, MPG, cylindrical, dispersion, HP, and car type, and name of the car. And if we see this, what happened? Okay, very simple. I will tell you what exactly regulation does. It reduces the coefficient. What is the coefficient? First, we try to find out the coefficient of MPG, coefficient of cylindrical, dispersion, HP, and all those things. Guys, are you understand or not? So here, when we say origin 1, 2, 3, look at this. Car dot drop car name. We drop this car name, isn't it, guys? We drop this car name and the next one. And then origin replace 1 to America, 2 to Europeans, 3 Asia. So here origin, we have 1, 2, 3. 1 means which brand cars, guys? American. 2 means European. and we call German brands car, isn't it? And three Asian brands like TC, Tata and Mahindra and all those things. We have Indian brand, okay? And then we try to get dummies origin. So when we do this, what happened? We create dummy variables or not? American, Asia, and all those things. That's clear. Model building. For model building, x-axis MPG, y-axis. I mean, what exactly? MPG, miles per gallon, is a dependent variable. MPG is a dependent variable. If I drop this, rest of them independent or not? Rest of them independent or not? That's why, even though without using ilog, you can drop this attribute data.drop. From the data set, if I drop MPG, that's my independent variable. And if I keep only, that's dependent variable. Are you clear or not? Now, processing dot scale, converting scaled data frame. What is the scale, guys? Standardizations and normalization. Split the data into X-train, X-test, Y-train. How many testing samples have been used? 30%. Means how many training? 70% training. Now let's build simple linear model. Linear regressions, X-train, Y-train, isn't it? And now the movement for IDX in enumerate, this is one of the, I will tell you guys what is meant by enumerate. Very simple. I gave you one of the book 185. Have you worked on that? Try today what is enumerate. Okay, it will give you some, it will give you, if not, I will take another Python class, I mean SQL class for you, okay, where I covered all the what is swap variables and all those things, guys, and how to find out like bit operators, bitwise operators, and lambda functions. Few things are there, I will cover in some other time. All right, and then once you find out intercept, regressions of model intercept, it will find coefficient. So coefficient of cylindrical is 0.32. Okay. And coefficient of for display is 0.32. Did you see all the coefficients or not? So what is regulation done? It reduced the coefficient, right? So here, how many attributes we have? We have all these MPG. These are the attributes we have or not? Let's copy. And once we do this, I found coefficient of 0.32. 0.32 minus 0.299. What is ridge regressions do, guys? It will reduce the coefficient. How it reduce? Look at the alpha equal to 0.3, isn't it? So penalty, what is meant by penalty? Alpha value. So ridge and model fit, when you do this, so first one, what is the coefficient of cylindrical? 0.32. When we apply ridge regular, it reduced to 0.31 or not? The coefficient reduced or increased? Reduced. Next one, 0.3248, 0.3132. It reduced or increased? This is what we learned. This is what we learned in ridge regularization. It reduced the coefficient of independent variable. Next one, minus 0.229. So this is minus 0.228, isn't it, guys? And then this one, minus 0.71, minus 70. And then here, 0.3752, 0.01. Did you see all the parameters, the coefficient values are reduced to reduce the overfitting problem? Team, understand? Now let's implement lasso here. In lasso, 0.3 and 0.1, isn't it? Because in lasso, we don't have square. But in ridge, we have a square. So when you have a square, the alpha value is very high compared to lasso. Can we say this? So once we apply, look at this, what happened? 0.32 has scaled down to, so how many attributes we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 11 attributes, 1, 2, 3, 4, 5. 5 attributes coefficient has scaled down to. So guys, are you understand or not? So what happened here? We notice many coefficient turn to 0, indicating drop of these dimensions from the building the models, guys. I hope understand. So that's why when we remove the element, the overfitting is reduced or not? The overfitting is reduced. Online team, I hope understand. Yes, Vinay, Yamini, and from where the alpha values came from. We have to define. Understand, Akshay? So that's called penalty. So if you check this, these are the parameters, alpha value. Do you remember we build the gradient descent or not? In the gradient descent, we try to reduce the loss or not? We try to reduce the loss. Yeah. So that's why when you do this, this is what you will get it, guys. I hope understand. Online team, are you clear? Online team. Can we use L1 in combinations with RFE to eliminate the features? See, RFE, you need to see the, yep. So I will tell you some of the machine learning algorithms itself inbuilt, they use L1, L2. Understand, Shashi? You need to do RFE on that case. So when we use L1, L2, inbuilt only they use regularizations. For example, I'll go ahead and I can show you right now one of the algorithms called sklearn SVR documentations. So right click, or maybe I'll show in futures where maximum algorithms we have L1 and L2, guys. So here C 1.0, just did you see C default 1.0 regularizations parameter or not? What are the regulations parameters? So here must be the penalty is a squared L2 penalty. Did I give you formula now? Guys, are you understand? So, Sashi, I hope understand, because all these parameters are inbuilt with all the algorithms. So it automatically done it. So manually, we cannot combine with RFE. Yeah, got it. Thanks. All right, guys. No, you got it, but everybody has to get it, right, Sashi? Anyway, we'll close this now. Next one. So today we complete regressions parts are completed, guys. Regressions topic completed, because yes, regressions we are pending. One is time series. I'll get back to you later. One is time series. I'll get back to you later. Everybody's clear? Now the next one, what are the performance measures for regressions, guys? R square and adjusted R squares. So today we learned classifications and the classifications algorithms. What is if the dependent variable is binary or category? Then we mention as, what we called classifications, guys. Do you remember classifications? The first thing, the performance measures of classification is confusion matrix. So she was talk about confusion matrix or not? So let's understand today. So this matrix sounds like confusion, but when I explain after you understand, there's no more confusion matrix, guys. In confusion matrix, there are four quarters, four sides. One is TP called true positive, and TN, true negative. And then we have FP, false positive. And then we have FN, false negative. You know, guys, when you see, this is very 5 minutes topic, but in LinkedIn, they will elaborate like 4 to 5 pages. I understand. So what happens if while you're driving, if you see a snake on road, you see and go, but they will elaborate a book that would be authored, that would be research. There's nothing makes sense. Very simple. You know what is this, where to use, and what is the application of it. That's it. Are you guys getting my point or not? Okay. This is very easy concepts, guys. I'll give you some of the example. Listen these examples, and I hope you guys are clear. Now, okay, in Lasso Ridge, I gave you a task. I want you to work on it. Okay, team? Okay, yeah. Now, classifications report. This is very important, and I'll tell you, statistics we connected to regressions or not? Where we connected? Where we connected? First, we build regressions table. Second, we call stats API. In regressions table, we learned t-test, and then t-table, p-value, and then significant level, R-square, adjusted R-square range, and over framework. Did you understand or not understand? OLS, very good. Ordinary least square also we done. Okay, OLS model also we built. So that's the way statistics we connected to regressions. Are you clear? When you go back 1 month back, I'll tell you I will explain statistics toward regressions. Now, are you clear? Are you clear now? So the same thing, statistics also integrated to classifications. How? Let me talk about this. I will give you one simple example. Listen to me well, then this topic is clear. Right now, we had a COVID symptoms or not, guys? A lot of students have died, a lot of them sick and all those things. Assume in confusion matrix, we have two part. One is actual part, one is predicted part. How many parts, guys? One is actual part, one is predicted part. So in actual part and predicted part, we have two things, guys. So the first thing, actual part and predicted. Assume actual means patient. Assume actual means predicted means doctor. Understand, guys? Actual means patients, predicted means, are you clear or not? So actually, patients thinks he don't have COVID. No means what? He don't have COVID. Actually, patients thinks he don't have COVID. But their parents, you go and meet to the doctor, it's better to final confirmations, right? So this patients go and meet to the doctor. Doctor said you don't have COVID. So both properties no or no. Doctor also said no. Patient said no. This is called true negative. What we call? This is called. Are you understand? Next one. Actually, patients thinks they don't have COVID. Okay, but the parents say to meet doctor, but doctor said you have. I mean, the sample is positive. So this is called FP, false positive. Do you remember in type 1 or type 2 error? Okay, there's example boy, girl, loves, all those things. Do you remember? Okay, you know, remember these things very well, man, isn't it? So anyway, so when you say FP, is it TP type 1 or type 2? This one, type 1 or type 2? Okay, you don't know. I will come back this one. This is called type 1 error, false positive. Very good, Ayushi. This is type 1 error. Isn't type 1 means what? Reject the true null hypothesis. Do you see how I connected statistics learning to machine learning classifications? This is the connections. This is the connections. Now, let's clear it and I'll come back to this one now. Wait. So let's complete this. Actually, patients think they don't have COVID, but doctor also said you don't have COVID. There's both conditions. No, we call as true negative. But patients thinks no, but doctor said you have disease, samples are out, and that's called FP is false positive. Understand him? And now, this part, are you clear or not? The first part, this one. This part, are you guys clear? Now, no and no, TN. No and yes, FP. I will show you practical every models like classifications from tomorrow, or maybe day after tomorrow, build the practicals, and then we see. And patients thinks he have COVID, but he meet to the doctor. Doc said no. That's called FN, false negative. That's called false negative. That's called false negative. But actually, patients thinks is COVID, but doctor said he has also COVID. That's called TP, true positive. So both conditions, yes, actual and predicted, yes, yes, true positive. Actual predicted, no, no, true negative, isn't it? So no and yes, false positive, false negative. So this is type 1 error or type 2 error? FP is type 1 error. FN is type 2 error. FP is type 1 error. FN is type 2 error. I hope you understand, everyone. I hope I'll give you, last time I'll give you an example. When both conditions false, no, then true negative. Understand, Saurav? Actual patient don't have any COVID. Doctor also said you don't have COVID, true negative. Clear or not? Doctor said you have COVID and patients also have COVID. That's called true positive. Clear or not? Okay. Now patients don't have COVID, but doctor said you have COVID. That's called a false positive. Doctor said you don't have COVID, then it is called false negative. Now, why we learn this? Because let's minimize. I will explain. So we have four things. For example, TP true positive. So FP also we call type 1 error or not? Type 1 error. And this one is type 2 error. This one is, so type 1 error and type 2 error, isn't it? Are we guys clear? Now, the formula of accuracy, the formula for accuracy equal to TP plus TN, TP plus TN divided by TP plus TN plus FP plus Fn. Understand this one. So how to compute the classifications model formula? I will explain all those things in practical. Just today, try to understand the equations. The equations are, just one moment. I'll go back and open the slide one more time. Accuracy. Assume overall we have 165 records. How many records we have? Out of 165, 50 records is TN, 10 is FP. So compute 50 plus 10, 60, 105, 165 or not? Now, for 55, 55 and 100, 110, 165 or not? So altogether 165, okay? Now, how to compute the accuracy of the model? To compute accuracy of the model, TP plus TN divided by total. So TN equal to 50 plus 100, 150 divided by 165. What is accuracy? 91%. If the accuracy is 91%, what is the error? What is the error? 9%, 1 minus accuracy. So 100 minus 91 is 9 point. Or other formula, FP plus Fn by total. This is error rate, guys. What we called error rate. 10 plus 5 divided by 165, 15 by 165, which is called 0.09. I mean, do you see every time we eliminate the FP plus Fn or not? So type 1 plus type 2 error, we need to eliminate. We need to eliminate. So error rate equal to, don't worry, calm down. I will show you practical day after tomorrow. You understand at this moment, very simply, I'm explaining how to compute error rate and TP plus TN plus FP plus Fn, isn't it? Are we guys clear or not? Are we guys clear how to find out accuracy? This is what interview questions, how to compute accuracy. You say TP plus TN by total. How to compute error rate, FP plus Fn by total. So FP plus Fn is also called type 1 error plus type 2 error. So this error means error rate or not? Error we never need to consider. So that's why we always need to reject the true null hypothesis or false null hypothesis. So in statistics, we call it as null hypothesis, but in machine learning, we call it as this one. So accuracy, error rate, are we clear or not clear? So, I mean, we have precision recall F1 score. I'll come back tomorrow. Okay, so I'll come back tomorrow. And then the first algorithms we covered is logistic regression algorithms. It will take 2 days to 3 days. We will build model on historical data, and how to predict the future also we'll do this one. So tomorrow, day after tomorrow, first 3 days is very important. I want you to attend the class because you build the future predictions. You build your future predictions. Are you guys getting my point or not? So I will stop here and okay, so here, let's go ahead. Let's minimize. Okay, we started working on like a review of previous classes, and we discussed formula sheets and also ranking table. See, whatever the prepared, I want you to, why offline didn't prepare ranking table? You haven't done? Because you watch IPL seasons, right? So guys, I would request you to please complete that. Whenever you work, you learn a lot of confidence, trust me. Please build the ranking table. And we discussed some ranking table as well. And we started working on regularizations. And regularizations, we have lasso. In lasso, what we call L1 or L2, guys? L1. In L1, it reduced the coefficient, high coefficient to 0, isn't it? To 0. But in ridge L2, it reduced the coefficients to up to 0. Up to 0. Right, guys? So this is also a regulation that help to overfitting. Regularizations will reduce, or isn't it? Yes or not? And also we see some of the practical about cars data set to implement regulations, isn't it? What else, guys? And we discuss, like, I mean, some students transitions, I mean, play students. I mean, we discussed play students, and we learned something from her, isn't it? All right. And then we confusion metrics. Confusion metrics, what is TP, TN, FP, and FN? No worries, try to understand today. And I will give you again confusion matrix. I'll explain one more time, and then we complete the confusion matrix. We start logistic regression algorithms, guys. See, buddy, weights. So when weights is nothing but that is the formula we will implement for use that algorithms KP. For example, when I start my engine, from where the engine works, how exactly the pressures are pumping up, we cannot understand all those things, right? So the same way, when we call the lasso from sklearn regressions, it can take care of these equations, guys, inbuilt. I hope I understand what I'm trying to say. Can we put his ranking table projects? No, Yamini, no, because that's not correct. So that you can do this. I hope on every record there's a weights, guys. So now there's some forces which we can't see. All right, guys. So when I throw the ball up, the ball goes down. So they have some weights that associate with it. And those weights are, I mean, it's a long story anyway. All right. So thank you. We connect tomorrow. And please build the ranking table this week. There's a lot of work for you. Okay. And we try to work on the model predictions as well. Thank you so much. And you have a good day. Bye, guys. Are you going to lab or not? Online team, what about you? You connecting every day? Okay. Thanks, guys. Bye.